Another question that I often get asked is, how do you do ABAC style things using relationship-based access control? If you're not familiar with ABAC, ABAC stands for attribute-based access control. And the way ABAC works is you're allowed to pass in a number of attributes alongside a permissions request. And those attributes get run through a policy. And then the policy makes a decision about whether the permission should be allowed or not. But just like RBAC, modeling ABAC can often be done natively, directly in relationship-based access control, or RBAC. And we've also extended SpiceDB with a feature that we call caveats to make some ABAC things that are difficult or impossible using relationships easier. So I'm going to walk through a few examples of how we can do ABAC style representations or ABAC style workflows directly in SpiceDB. Okay, so starting from our standard RBAC schema, we're going to go ahead and add some ABAC style things. So one thing that we get asked about is sometimes documents are high sensitivity. And in order to be able to access a document, the user must have an equivalent level to the sensitivity of the document. So in ABAC, this might manifest itself as saying like document requires clearance. And we could say high, for example, and then we could say like user clearance is medium. Right, so these would be attributes that would be fed into a policy engine, and then the policy engine would compare high does not equal medium, or high is, medium is not higher than high. So therefore, we're not going to allow anybody to read this document. So one thing we can do is, because these attributes are on the users in the documents themselves, and they seem relatively static, we can actually encode them directly in relationships. So I'm going to go ahead and add a clearance level object type, and I'm going to say possesses, POSS, yeah, that might be right, I don't know, close enough. And we're going to say that users possess a certain clearance level. Okay, so I'm going to go ahead and give, let's just get rid of Tom to make it easier. We'll get rid of this stuff as well. I'm going to go ahead and say that Fred, user Fred, clearance level medium, possesses user Fred. Clearance level medium, got my hashes mixed up. All right, so Fred has medium clearance level. And we also want to be able to define a requirement on the document. So here we might say requires clearance level, required clearance level, and we might say that clearance level possesses, right? So the people who possess the required clearance level will meet this, will bind a clearance level as a requirement to this particular document. So the way that would look is we would say document first doc required clearance level high. Okay, but it's not just high, it's the people who possess high. Okay, and now Fred only has medium, but we require high for the document. So we should see Fred disappear, except that we actually haven't imposed, we haven't actually required that the clearance level be used in our permissions calculations. So what we can do here is we can say that in order to edit a document, you need to have both writer and you need to have the required clearance level. Similarly, right, to view the document, we could say that you need to have reader and the required clearance level, or otherwise be allowed to edit the document. And now we should see that Fred disappears. If we add another user that has the required clearance level, So let's say we add Tom, to go back to our original example, and we give them hi. But we also have to share the document. Oh, sorry, no, we already did that. So now we should see Tom is allowed to view the document because Tom has both the required high clearance and is also a reader of the document. But we have an interesting case here because high, medium, low, those are related to one another, right? So if, for example, we had another document that required, or let's say let's say we just change this one to medium. Now we should expect to see both Tom and Fred. But in fact, we only see Fred because we haven't actually linked the clearance levels together. And so what we can do here is we can say superior to clearance level yeah, I think just clearance level. And then we'll have direct grantees of type users. And then we'll say possesses is clearance level, we'll say direct grantee plus superior to possesses. This is a permission now. Okay, now we'll need to fix up a few relationships. We need to do, this is a direct grantee. This is a direct grantee. And now we can say that the clearance level high is superior to clearance level medium. And we can also do medium is superior to clearance level low. All right, and now still not working. Let's see if we can figure out why. So let's see, let's start with clearance level low and see who possesses that. Yep, nobody. Let's also do medium and high. High. Okay, so we see that Fred possesses medium, and Fred and Tom possess high. I think we may have gotten that backwards. So let's see, clearance level, direct grantee. So Fred is medium and Tom is high. Right, okay, so it's not superior to, it should be inferior to. And then we have to swap these all. Inferior to, so low is inferior to medium, and medium inferior to high. So high is just Tom now. Low is both of medium and high. Medium is both. And now Tom and Fred can both view the document, but if we upped the document's required level, so if we required high, then we would now see that only Tom is allowed to view the document. So this is a way to take things that might otherwise be attributes and distill them into relationships. And this works under two scenarios. One is that the attributes that we're passing in are not contextual. They're not rapidly changing. They're not something that might change with every single request. And the other way it works is if the attributes, are not, they don't need to be compared on like a numerical level, right? Another example that we can model in just a second might be like this person is only allowed to approve or to check out this shopping cart if the total value of the cart is less than $100. And you could see that it would be difficult to distill that down because $100 can't be quantized. It can't be turned into, I mean, theoretically, you could turn it into 100 different values for the shopping cart, but because it's infinitely variable, we wouldn't want to have a relationship for every possible value of the cart. And so that's where we go and we reach for this functionality that we built into SpiceDB called caveats. So I'm going to go ahead and swap back out for a very simple example. We'll just start with users. And let's do what we just talked about. Let's create a shopping cart example. So let's say cart value is $49.31. And then we would say that user can approve if less than 50, right? So here we've got two numbers. The interesting thing is that only one of these numbers, the cart value, is probably changing on every request, but the user approval threshold can actually be encoded into the system ahead of time. So let's go ahead and model it out and see what it looks like. So let's do cart. And then we're going to want to see who can approve the cart. Right now, we don't have any way to know that. This cart is probably going to belong to an organization of some sort. Think like a shared corporate Amazon account. And then here we're going to have cart approver. Okay. And then let's write a caveat. So our caveat is going to be approve if over, approve if under. And then this is going to take two parameters. This is going to take the max approval value, and that's going to be an int. And it's going to take, I guess it should probably be a float. And it's going to take the cart value as a float as well. And then this is a cell expression. Cell is Google's common expression language. And so here we're going to evaluate this to true if cart value is less than or equal to max approval value. Okay. Max approval value, unknown type float. Oh, let's pop open the cell docs. Google cell. Types. Google cell types. Type values. Int, string, false, float. Float literal. No, double. Okay. So usually for money, you don't actually want to use a double or a floating point precision, but I think it'll make the example less clear. What you would do is theoretically, actually we'll do it this way. Max approval value cents, cart value in cents. So you want to use an integer value for anytime you're dealing with money, because you don't want floating point, the imprecision of floating point math to give you incorrect answers. So, all right, now we've got our expression written. At the organization level, we're going to say a cart approver. We're going to change it to a type user. with approve if under. So this is the way we say, we're defining a type, and we're saying that the user, we're accepting users here, and we're accepting reference to a caveat as well. And we're going to use that caveat to essentially allow a person to be a cart approver or not. And then here we're going to have relation org is of type organization. And then the approver will be the org's cart approver. All right, so far so good. The rest of the magic of caveats actually happens in the relationships. So what we can do here is we can go into test relationships, and we can say, we'll have a cart, Jake's shopping cart. What did I call it? Cart, yeah. Belongs to org, organization, org1. Okay, and then we'll say organization org1 has a cart approver of user Jake if approve if under. So here we're binding the cart approver to the specific caveat. And now we can actually write an assertion that includes, let's say, document, we're not using documents anymore, cart Jake's shopping cart. And we're going to say approve. And then we're going to pass some data. User Jake, and we're going to say with. Actually, let's just see what happens right now. So it's saying false. But we can add some context to this. So we could add parameters where we could say max approval value cents. So $50. And then we could also pass the context of, and when we work with caveats, we have to put this all in quotes. Cart value cents. So now we're going to say that the cart value is $45. Now let's see what happens. Nope, doesn't like it. Parsing caveat, context, and assertion. Invalid character C, right? So this needs to be quoted. And now let's see what happens. Fails to validate. That's just this part. So there, it worked. And then we could see what would happen if the cart value were $50.01. This fails. And the reason is because the relationship no longer exists. It becomes invisible to SpiceDB if the caveat expression fails. So we can write assert false here. So we can have 45 works, and we can have 50.01 does not work. Okay. And then the last part to figure out would be on the relationship. So this approver, like I mentioned earlier, this approver value actually is probably static for a user, or it's configured on like a user management panel. So over here, we can do approve if under, and in the context, we should be able to say max approval value cents. And then we should say $50. We can set that as the context. And then now these should still work, but we should be able to remove these attributes and only pass in the cart's current value at assertion time. And it all works. So you can see that basically what we're saying here is when we write the fact that Jake is a cart approver, we can also set the threshold for which Jake can approve carts. And if that changes, right? Like let's say we drop Jake's approval level down to $40, then this will now fail because 4,500 is greater than 40. So we can have context coming from two different places here. We have context that can be stored with the relationships, and we can also have context that's passed in at request time. And this is how we get these style of ABAC policy decisions built into SpiceDB. I like to refer to it as a tiny amount of policy that gets sprinkled into each relationship. And then as we traverse the relationship graph, we assemble all of those micro policies into sort of a minimal policy for any individual permission decision. And that's it. I hope this was super helpful and enlightening and taught you how ABAC and ReBAC can come together. Thanks.